This is the video for section 6.2, substitution. And what we're doing in this section is that we're still solving for system of equations, which, remember by the previous section, is that we were looking for the intersection levels of lines. And that was going to end up being our solution. How we stated our solution was an ordered pair. For example, 3, 2, and where we had an x and a y value of that intersection. So we're doing the same thing. This is just a different method where we're going to substitute in equations. So if you'll fold your foldable towards the words substitution. And there's several scenarios that we can have. The first scenario is this: when one equation is set equal to a variable. That means that it has a y equals or an x equals. It really wouldn't matter which variable it's set equal to, nor if it's the first equation or the second equation. You just take the other equation, and instead of writing the variable, for example, y, we're going to substitute in the value of y, which happens to be 2x plus 1. And that is the y value, and so it's still set equal to negative 12. From there, we go through the operations to solve for the variable. So let's take a look inside and see how that's done. All right, so this one right here, it has an x equals. So that's the one you're going to substitute into the other equation. Be careful, it tends to happen that students substitute in the wrong variable. This one's x equals, so that's why we're going to substitute it in for the x. It looks like 5, and instead of the x, we're going to put the x value. And then it's still minus 2y is equal to 7. From here, we do the operations to solve for the variable. First, the distributive property. That means 5 times 3, which is 15y. 5 times a negative 9, which is a negative 45. Minus 2y, because we're just writing the rest of it down, is equal to 7. Now we're going to combine like terms. That's 15 minus 2y, which gives you a 13y. And we're still got to write down that minus 45 is equal to 7. Now we're going to add 45 to both sides. 13y is equal to 52. Now we're going to divide by 13. Y is equal to 4. So from here, remember, we still need that x coordinate to give us that order pair. So we got to solve for x. The way you solve for x is, since this one already says x equals, you're going to take this equation and you're looking for what x equals. But now instead of writing y, we're going to substitute the value of y. And then this is still minus 9. Well, 3 times 4 is 12. We're still got to write minus 9. So x is equal to 3. Your order pair is 3, 4. That means that that will be the intersection of this system of equations. Let's try that again. So this time we have a y equals in that second equation. That means that we're going to use that first equation. Negative 6x plus 3y. But instead of writing y, we're going to substitute that value, which is 2x minus 4. Then we keep writing it equals negative 12. We're going to do the distributive property first. 3 times 2, negative 6x plus 6x minus 12, because 3 times negative 4 is negative 12, is equal to negative 12. Now we're going to combine like terms. A negative 6x plus a 6x becomes a 0x minus 12 is equal to negative 12. So this says 0 times x, so we don't really need it because that becomes 0. We don't need to add or subtract it. So we're left with negative 12 is equal to negative 12. Well, that's true all the time. Negative 12 is negative 12. That means that this is always true, making it infinite solutions. So when we were graphing them and they became the same line, we knew that they had infinite solutions. Well, this works exactly the same way. You don't need to write this down, but this is just a side note. And I'm going to take that second equation and I'm going to solve for y. So I got to add 6x to both sides. 3y is equal to 6x minus 12 divided by 3. Y is equal to 2x minus 4. Look, it's the exact same line, and that's how we're supposed to know that there's infinite solution. But this is by method of substitution. When the two sides are true, then, when the statement is true because the two sides are the same, then that's how we know it has infinite solutions. So let's take a look at another scenario. How about if there's no equation set equal to a variable? So what you're going to do is find that variable that doesn't have a coefficient. A coefficient was the number in front, remember? And that would be the easiest one to solve for. But really it doesn't matter if you solve the first or second equation or for x or for y. You're still going to get the same value. All right, so this one says 2x plus y is equal to 10. We're going to subtract the 2x from both sides. Y is equal to negative 2x plus 10. Now that it's set equal, then we substitute it. So don't forget, if it's a y value, substitute it for y. If it's an x value, substitute it in for x. So this one's a y value, so I have 4x plus 2. But instead of writing my y value, I'm going to write what my y value can be set equal to, which is negative 2x plus 10. And that's equal to negative 3. I'm going to do, from here we're supposed to do the steps to solve for the x, but I'll show you on the inside of the folder. All right, so take a look. Which variable would you solve for? I'm going to solve for the y. It's the only one without a coefficient. But like I mentioned before, any variable that you solve for would work out. So I have y minus 3x is equal to negative 13. So to solve for y, I'm going to add 3x to both sides. Y is equal to 3x minus 13. Now I can substitute in this value into that second equation. So it's a y value. For x plus 5, but instead of writing y, we're going to set what y equals, which is 3x minus 13. But that still equals 11. So remember, you were trying to rewrite the first one with the substitution of that y value. Now you're going to do the distributive property. That's 5 times 3x. I'm going to rewrite 4x plus 15x. Negative 5 times a negative 3 gives me a negative 65. That's equal to 11. Now we're going to combine like terms. 4x plus 15x is 19x minus 65. It's still equal to 11. We just rewrote the rest of the equation. And then we're going to add 65x to both sides. 19x is equal to 76. Now we're going to divide by 19. X is equal to 4. So you have a x, now you need a y. So again, how we solve for the y is that we take the one that's y equals. You can use this equation, but I'm going to set this one because it's already set for me to use the x. So y is equal to 3 times 4, because that's the x value that we solved for, minus 13. Y is equal to 12 minus 13. Y is equal to negative 1. That means that this ordered pair is 4, negative 1. Don't forget, in an ordered pair, you have to rewrite the x first and then the y. And that's why I put 4, negative 1. On the next one that we have over here, I'm going to solve for this one. Like I mentioned before, it doesn't really matter if you solve for the x or the y. Just going to solve for the y on this one. That's what we're used to more often. So x plus y is equal to -5. So I'm going to subtract x from both sides. Y is equal to -x minus 5. And then I take that y equals, and I substitute it in for my y variable here. So I have 4x minus 5, but instead of writing the y, I write -x minus 5. That came from here. And that's still set equal to -20 because you're substituting it into that second equation. I'm going to do -5 times -x. 4x minus 5, it's going to be a plus because a negative times a negative is a positive. Positive x, and then a positive 25. Because -5 times a -5 becomes a positive 5. And that's equal to -20. Combine like terms, I have 9x plus 25 is equal to -20. Subtract 25 from both sides. 9x is equal to -45. You divide by 9. X is a -5. Okay, now that I have an x value, I'm going to substitute it in for the y value. In the y equation, which gives me y equals negative, because it's part of the equation. And then I'm going to put it in parentheses, -5, because that's the value that we solved for. And then minus 5. Negative times a negative is a positive 5 minus 5, which will give you 0. The order pair then would be that -5, 0, because the x goes first. Not because you solved it first, because the order pair says x, y. And then the last scenario that we have over here is when both equations are set equal to each other. When they're set equal to each other, you just, set them equal to the same variable. So as you can tell, it says y equals y equals. You set them equal to each other. What does that mean? That means that x plus 5 is equal to -x plus 3. They're both equal to y. And then you go through the steps to solve for the variable. Okay, this one says x equals, and that's how we can set it equal to each other. 3y minus 6 is equal to y plus 2. Now we're going to solve for y, minus y to both sides. I'm going to go ahead and add 6 to both sides. 3y minus 1y is 2y. 2 plus 6 is 8, and then we're going to divide by 2. Y is equal to 4. That's our y value. Now we need our x value. It really doesn't matter which equation you set it equal to. I'm going to use the first. Well, let's use the second one. Let's use the first, just to make sure that either way you're going to get the same answer. X is equal to 3, and now we have the y value, 4 minus 6. X is equal to 12 minus 6. X is equal to 6. The x goes first. 6 comma 4 is your final answer. Well, let's take a look. I said, well, let's use this one just to make sure that you would get the same answer. Look at this one. This one would have been way easier to substitute it in. If we said 4 plus 2, it would still give you 6 and giving you the correct answer. All right, let's try that again. And they're set equal to each other, so that we, because it says y equals, so 2x plus 5 is equal to 2x minus 5. Now we're going to subtract 2x to get rid of it here, minus 2x to get rid of it here. You can go ahead and subtract 5 to get rid of it here, subtract 5 over here. But I want you to notice there's nothing left over here, so we write 0. Because that was 0, that was 0. We have nothing over there on that side, that's 0. And then 0 is equal to -5. 0 is equal to -5. That's not true. That's false. Since it's not true, that means it is no solution. So just to remind you, when we were doing the equations and graphing them, if they had the same slope, we knew that they were parallel and would not intersect. So this one would again have no solution.